Hi and welcome, lads. Today we're talking about Bubblesort, which is a sorting algorithm, and we're going to implement it in Python. Alright, so let's get right into it. Well, Bubblesort is one of the basic algorithms for sorting data, and it has its name because the greater elements rise like bubbles and the smaller elements fall down. So it is a sequential algorithm that goes sequentially through the data and compares and swaps if necessary. Alright, it is an in-place sorting algorithm, basically meaning that we don't need extra data storage, or we don't have to store our data in another way or list. So we can basically do it right in place apart from the swap operation, but that's usually just one element of our data array. And the time complexity is kind of bad, it's n squared, but it is what it is a basic algorithm. Alright, so let's go through an example. Well, we have the initial list that is here 75, 38, 42, 1 and 10. Alright, in our first run we check our first element here and we compare it with a second element. So if 75 is bigger than 38, then we have to swap it. Alright, so we do so. In the next step we have to compare 75 to 42. It is greater again, so we have to swap it again. And we do the same for the 1, and in the end we do the same for the 10. And as you can see, the 75 is the biggest element here, so it is bubbling up, it's rising in our data array. Alright, so in our second run we compare the 38 with the 42 again, and there we don't actually have to swap because the 38 is bigger than the 42 already. But in the next step we compare the 42 with the 1, and there we have to do the swap. And the same we have to do also for the 10 in the end. Alright, the last step we don't have to do, because in each step the biggest element of the array is already going to the end. So in the first it's the nth element that's going to be the largest or the greatest one, and in the second run it is the nth minus 1 and so on. Alright, so let's have a look at our third run. So we have to compare the 38 with 1, and that is going to be bigger, so we have to swap it. And in the next step we have to swap the 38 with a 10. Alright, so and in the next step, in the fourth run, we would compare all of them and figure out that we don't have to swap anything, and there we can stop. And there we also see the time complexity. The worst case is actually when we have to go and swap all of the elements in our data array. And that would be if the data array is sorted in reverse order. Alright, so let's go ahead and implement it in Python. I create a new file called Bubblesort, and we create a class named Bubblesort. And then in this class we want our sort function or method, and that gets self because that is necessary in Python, and it gets our data array. Well, let's just make some comments here straight away, because the data is expected to be a list of numeric items. Alright. So as we already saw, we have to go through we have to do n runs in worst case. So we say our n is the length of our data array. And then we can start our first loop, and we say if n is greater than 1, and we do that because if we just have one element left, that's naturally sorted. So we can go in there and do our number of runs. And in the second part we have to swap and compare the elements. So we are using a for loop there, and we say for e in range. So we basically get all the numbers in the length of our data, and we want lang data, and we have to use -1 here because we start with our indices at 0. Alright, and then we have to check if our data array I, so that's our actual element, is bigger than its successor. So we have I plus 1. Then we want to do something like a swap operation, and that we want to do that on our data array and our E, I and J element. Alright, so then we have to implement our swap method, and we say that let's do it as a private method. Swap, we need self, our data array, we need I, and we need J. And we can also say here swaps two elements of the data array or list, and returns a copy of the swapped array. Alright, so we do it by using a temporary variable, and that is our data I for the moment. And then we can say our data I is our data J. And then we need to set our data J to our temporary variable, and then return our data array again. Alright, so then we have to say here our new data array is the one with the swapped elements. Alright, so in the end we just have to decrease n, and so we say n, we decrement n by 1. Alright, so we can also reduce the amount of steps here a little bit. If we say was swapped, for example, we set that to false, and if we do a swap, then, oops, that's not, I just saw that that's not J, that's I plus 1, it's a successor. Alright, if we swapped something, we say was swapped is true. And then we can say here if was swapped, then we decrease that by -1. And if we didn't do any swap, then we don't need to continue because everything is sorted already. So here we can do a break for our while loop. And in the end, we just need to return our data array. Alright, so that should make the deal. Let's do a quick comment here that are our runs through our runs until sorted. And here we say that is our compare and swap operations. Alright, so let's try it out. We say if name equals name, then we say our sorter is, we need to create an instance of our class, and then we create our data and we say some random numbers, 1, 99, 42, 17, 23, 9, -5 to check that, and do twice -5. Alright. Yeah, that should make it. That should be fine. And then we say sorter.sort, and we say, oops, data. And because we just want to check if it works, we just print it for now. Alright, so let's run it. And as we see, here is our array that we had before, and that is our array how it should be sorted, and that looks really good. Alright, so that's it for now. That is the Bubblesort algorithm. If you liked the video and if it helped you, then give it a thumbs up and subscribe to the channel if you want to. Alright, have a nice day, see you soon, bye.